Hello viewers, in this session I would like to discuss on elongation of uniform circular tapering bar under axial load. As you can see in this image, we have a tapering section. The tapering section is acting having a D1 diameter at this end and D2 at this end, and which is tapering uniformly from D1 to D2. And the bigger end what we have, that is D1, and smaller end is D2, and both ends are subjected to the axial load P. And here I have considered some elementary strip. That elementary strip is provided with dx. The length of that elementary strip is dx. To this dx we'll calculate the elongation first, and later we'll integrate it from total length from 0 to L, right? Here what I do, I will first consider this elementary strip. So that is what I have discussed. So on this elementary strip, whatever the total force is acting and the total elongation is expected, and similar kind of deformation is expected throughout the length. So now what I do, I will take this diameter of elementary strip, which is dx, right? The elementary strip dx, what I have taken this one. So that diameter what I can write, so in the total D1 is a higher diameter, higher end of the bar, right? And I will take this D1 minus D2 times x divided by L. So I will write this dx strip, diameter of the elementary strip, that deducting the whole maximum diameter, that is D1 minus D2 times x. X is the distance acting from bigger end to the elementary strip, that is the distance, right? So D1 minus D2 times x by total L. So now for simplification purpose, what I do, I will take this D1 minus kx. I will rewrite this like D1 minus kx. So what is meant by k now here? K is equal to D1 minus D2 divided by L. D1 minus D2 by L is the k now, just for a simplification purpose. So after that what I do, I will take the cross section area of this strip. So my aim is to take the stress in the strip and strain in the strip. So once I get the strain, I will get the total elongation. So once I get the total elongation, I can make it to the total length. So for that I need stress in the strip. To get the stress, I need the cross section area, right? So cross section area of the strip, cross section area of the strip, what I can write, that is Ax, since the strip is denoted as dx and the diameter, and the area is denoted as Ax. So what I can write, I can write pi by 4 dx square. Since it is a circular section, so it is the cross section area is pi by 4 dx square. So dx is what I can write, this one, dx is this one. So pi by 4 times d1 minus kx whole square, that is Ax. Okay. So now I will write stress in the strip. Stress in the strip. So what is stress? Stress is sigma. In this part notation we do usually note it, and the stress is nothing but load by area, right? So P is again, it is nothing but P itself, since the either end is acting with a P, that is P load, right? And A is the cross section area of an elementary strip, that is pi by 4 d1 minus kx whole square, right? So now what I do, I will just rewrite this equation, rearranging the terms. See, this 4 will from denominator to numerator, that is 4p divided by pi times d1 minus kx whole square, right? This would be the stress in the elementary strip. So now what I do, I will write this for strain, right? I will write this for strain in the elementary strip. So how do you note the strain? That is in this type, that is strain x. So strain can be written as that is stress by Young's modulus, right? So using this one, Young's modulus equal to stress by strain, we have this equation, basic equation, rewriting in the form of strain. So what I can write, stress by Young's modulus, right? So that is what I have written here. So strain equal to sigma x by E. So sigma x is stress what we got, this one, right? So 4p divided by pi d1 minus kx whole square whole divided by this term E. So if I rewrite this equation, it is 4p 4p divided by pi d1 minus kx whole square times E, right? So after this, that dx will be taken, this term, that is dx is written here itself. So if that is if I write it for strain in the elementary x, right? If I write this for strain in the elementary x, so now that I will take in the next step. So I do not write here. Okay, now so later after this, what I can write, elongation, total elongation in the strip. So first I will take it for strip and later I will get into the total length. So elongation in the strip can be written as delta L. I am taking this small delta because I am doing it for a small area, and later I will go for the total area, that is strain with respect to dx, right? So strain with respect to dx, what I can write, I can write this equation similar, 4p by pi d1 minus kx whole square times dx. So this is what the elongation in the strip dx. So later on this, what I do, I will take it to the overall length, right? What I do, I will take it to overall length to write that the total elongation of this tapering bar can be written as by taking the integration from 0 to L with a lower limit of 0 and upper limit of L. So what I can write, that is the total length, change in length is from 0 to L. So this is the elementary strip, 4p by pi times d1 minus kx whole square dx, right? This is the part of our length change in the elementary strip, and I need to hit from 0 to L. So if I take these constants outside, 4p divided by pi, right? So 4p by here I have got, that is E, right? So here I need to write this E. So this 4p by pi E is taken outside, and the rest of the things is determinant, that is dx by 1 minus, that is d1 minus kx whole square, right. So this is what dependent variables, that is dx by d1 minus kx whole square. So now I need to resolve this for to integrate from 0 to L. So this particular part looks like 1 by x square, right. So 1 by x square, the integral of this 1 by x square can be the integral of 1 by x square is written as minus 1 by x, right. So I will take that part here. This 4p by pi E is as it is. So this integral of this 1 by x square I do write in this form, that is minus 1 divided by d1 minus kx, right, this dx written as it is. So now for this, if I want to take this dx out, what I need to do, I need to divide this with a constant, that is minus k. So for that, what I do, I will take this 4p by pi E from 0 to L, this minus 1 times minus k, because k is the constant is associated with minus k, and if I divide that, if I divide this minus k here, and it will go on the numerator. So that is minus k, minus 1 by minus k, that is d1 minus kx, this part, right. So now what I do, I will rewrite this in the form of in the simplified form, that is 4p by, what I do, I will, this is k, this is minus 1 into minus k, it is plus k. So pi E, I will take this k at this point, and this numerator part will go on the above, right. So what I do, I will write this d1 minus kx like this, and I will upload, I will input from 0 to L, I will substitute the limits from 0 to L. So 4p by pi E k 1 by d1 minus kx. So what I can write here, substituting this, first I do substituting the value of k. So value of k is d1 minus d2 times x divided by L, right. This is what we have written at the first step. So now that is to be substituted here. So here if I write, this is 4p by pi times E, k is d1 minus d2 times x divided by L times one by d1 minus d2 times x by L, right. This is from 0 to L. So now if I substitute this L in the equation for the at the place of x, so this x will go at the numerator, right. So what I can write, 4p L by pi E d1 minus d2, yes, d1 minus d2, this L is at the numerator, times. So if I write this, so what I can get here, this minus plus d1 and minus d1 will get cancelled, right. So after that it is remained with 1 by d2. If I substitute this L, so So this is 1 by d2 minus 1 by d1. 4pl pi e d1 minus d2, this is 1 by d2 minus 1 by d1. So what I have done here, what I did here, I did substituting of L and 0. So if I substitute 0 here, if I substitute 0 for this part, so d1 minus d2 will become 0 because it is multiplied with 0. We are remained with 1 by d1 at this part, at the lower part, right? And for the upper part, if I substitute L here, this d1 and this d1 will get cancelled, and this is d2, right? And this L and this L will get cancelled. So that is why 1 by d2 it is, and this is minus 1 by d1. So now the equation can be written as, 4pl by pi e d1 minus d2 times d1 minus d2 by d1 d2. So which is nothing but 4pl by pi e d1 d2, right? This is what the total elongation of a circular tapering bar. Thank you.